oil can shaped like a right circular cylinder, what dimensions will use the least material?
That requires to know the formula for a cylinder.
Yeah, I don't know. Yeah. I want to use the least amount of material.
Was it AP test when they give us the formula, or?
Ooh. I believe, well,
I feel like they should.
I think they would, but there's a few that you should probably kind of throw into your, bag of formulas and have memorized. Volume of like that last one, you should know that the volume is, the height times the base. Probably the cylinder one, you should probably know too. The cylinder question and the previous question and that box question where you cut out the corners of the box, those are all really common, kind of the standard calc problems for optimization. And especially the one with the river, where you got three sides to a fence in your. I'm just going to give you we're going to use centimeters cubed because when we talk about like the height of this cylinder, we're going to measure it in centimeters probably. We're not going to measure it in, I don't know, something to do with meters. I don't know, we're not going to use standard just measuring. We're good?
I think so.
Okay, so once it's gone this time, it's gone forever. All right. All right, so what should we do first here? We'll call this the cylinder bubble. Or oil. All right. First thing I would do is draw a picture, right? Yeah. I'm really good at drawing cylinders.
Is that sarcasm or no?
I know you'll find out. That's not too bad. When I first learned how to draw a cylinder, I was so proud of myself.
When was that?
Oh yeah, the ball. Yeah. When was that? That was like a year ago. All right. What do I know about this thing? What did they give us in the problem?
Has to be 1,000 liters. It can hold 1 liter of oil.
Yeah. The volume is 1 liter, which is what? 1,000 centimeters cubed. I like to write down everything that I know. That's good. Start. Now, there's a couple things that are important in a cylinder. The radius is important, and probably the height is also an important factor. And can I write some sort? Well, first of all, what am I trying to do? I'm trying to minimize, maximize. Minimize what? Surface area, right? So I want to minimize surface area. What is my formula for surface area? In fact, let's call it, we just call it A for area. Surface area equals, what's my formula for surface area of a cylinder? Pi r squared times h. I think that would give me the volume. Right? If I was thinking about surface area, I've got the surface on top. What is that? 2 pi r. Well, hold on. No. The area of the circle on top. Just the circle. What's the area of the circle? Pi r squared, right? Area of a circle is pi r squared. What's the area at the bottom? Pi r squared. So, 2 pi r squared. That's first. And then what is the area of the piece around the cylinder? Yeah, the circumference of the circle times what? Times the height, right? So plus 2 pi r h. Okay. So that's the function for area. We want to minimize the area on this thing. Problem is I've got it in terms of r and h. So similar to the last one, I've got to develop some sort of helper equation here. So happens to be that I know the volume is 1,000 cubic centimeters. So let's write some sort of equation for volume. 1,000 equals, what did we say volume was? Pi r squared times pi r squared h. Pi r squared h. Good. And if I want to solve this thing for, well, we can do r or h, but let's solve it for h. I think that'll be easier. I'm going to divide both sides by pi r squared, pi r squared. Gone. I'm left with h equals 1,000 divided by pi r squared. Any questions on how we found h or y? Okay. Let's substitute everything back in. So a equals 2 pi r squared plus 2 pi r times h, and we said h was 1,000 divided by pi r squared. Okay? Let's look at the whole page of notes, but kind of off topic. All right. Can we simplify this before we move on? Maybe we can take the derivative of that, but it wouldn't be that really fun as it will be after we simplify. What's 2 times 1,000? 2,000, so plus 2,000, and then I think the pi's go away, and the r stays on top, right, divided by, oh I'm sorry, the r's go away too, right, r's gone, and I've got an r at the bottom, okay. Cool. Questions? Alright, now what? Take the derivative, right? We want to minimize the area, so we want to find the minimum of this graph, so I'm going to find a prime. A prime equals, let's see, 4 pi r plus, what is this going to be?
Negative 2.
Yeah, are we okay with y?
We did this
Yeah.
earlier.
Okay, alright. So, minus 2,000 over r squared. Okay. And this is starting to look a lot like the previous one, right? Solve this thing for r. In other words, find when a prime is 0. And so I've got 0 equals 4 pi, pi r minus 2,000 over r squared. I'm going to add the 2,000 r squared to both sides, so everything's positive. No, it doesn't matter. Divided by r squared equals 4 pi r. And what do you want to do next to solve this thing for r? Multiply both sides by r squared. Okay, so I get 2,000 equals 4 pi r cubed. Divide by 4 pi. Okay, so I get r cubed equals 2,000 divided by 4, 500 over pi. Am I going too fast? Okay. Last thing I do to solve this thing for r, this doesn't come out as nice as the last one, right? Cubed root, and I guess we can just estimate, what is the cubed root of 500 divided by pi?
5.42.
What was it?
5.42.
5.42. Alright, so that's the radius. What was the question asking? What dimensions will give us the least material, right? Well, the radius is certainly one dimension that I need. But what else am I going to need? The height, right? So how am I going to figure out the height? Right, this thing, right? Yeah. Okay, so to find the height, I'm going to go h equals 1,000 divided by pi r squared. And in fact, let's just substitute in r. I don't have to write it again. Times 5 point, my goodness, 5.42 squared. And that's something that I can click into my calculator and figure out an answer for. So what is h then? 10.84. Interesting. Danny said it's twice the radius. So if we wanted to minimize the material used or minimize the surface area for any right cylinder, what kind of general dimensions should we have? 2 to 1 of the what? Yes. The h has to equal 2 times h equals 2r. Yeah. And that's for any right cylinder. This is Mr. Cresswell. Oh, she is in room 100 this hour. Yep. No problem. Bye. Biggest part of the lecture, wrong number. Okay. Anyway, yeah, so for any right cylinder, h equals 2r. In other words, the height of the cylinder needs to be twice the radius. It's actually, I think, kind of an interesting result. Maybe you don't agree. And ultimately, I really don't care. But I think it's interesting. So, what you could do is you could go home and find an oil can and then measure it and see if it's actually built to, if the companies are actually using the least material. Do you think that they are? Why wouldn't they? Why wouldn't they? What would be a reason you wouldn't minimize your material?
To cut costs.
Maybe to increase the price. What?
I think because they're stupid.
Because they're stupid. How that could. What? Any other reason?
To cut costs. No.
No. We'll come back to that question. I don't want to give you the answer. Okay.